Hey guys, welcome to another week of online learning. This video is our science video for the week. This one for science, you guys have 3 items that you're doing, but only 2 that you turn into me. One is the test on states of water, and the other one is the writing paragraph for science. The rest are just review items. So I'm going to walk you through item by item. So you guys have been talking about water, how it boils, how it freezes, the freezing point, the melting point, also how it evaporates when it melts. It evaporates up into the air. And I'm going to actually pull up this handy little water cycle chart to go over it with you. So we have water. Let's just say it's in a lake or in the ocean at the beach. The sun is so hot that it actually causes this liquid to turn into steam. And this is called evaporation. So just like when you boil water for pasta and the liquid starts to become boiling into a gas, like a steamy vapor, that's basically what happens in our air, and it comes up and it's called evaporation. And you guys probably know that from earlier than 3rd grade. But here's where things get a little tricky. So then this turns into condensation. So this process is from when it turns into that like steamy liquid, and it actually cools and it starts to become a liquid again. So it goes from a gas to a liquid and it's cooling down. So that's like kind of when you see droplets forming on like the side of your cup. I would call it like the water beads, or like when your water bottle sweats. That is called condensation. Precipitation is when it actually falls down into our atmosphere, into our homes, our cars, everywhere. Snow, sleet, hail, rain, all of that, depending on the temperature. So if it's 32 degrees or colder, it is snow. But if it's warmer than 32 degrees, which in Florida, it's almost always warmer than 32 degrees, it's rain. So we get the rain. And then it starts over again. So I like this little picture. I think it was like a good handy way to just look at it quickly. So the first thing that I asked you guys to do first was your concept review game. And this game you actually can only do one time. So I didn't realize that until the 3rd grade teachers and I were talking about it. And she was like, you can only play that once. And we were like, oh no, like that's not the point. We want you guys to study. So you can break it down into key terms or concepts, or you can do both right here. So I'm going to do both and I'm going to walk it through it with you. When something is freezing, what happens? You guys know this because of things like ice. Freezing. So does that mean that we classify something as a solid, liquid, gas? Is it something that living things need to survive? Do we need freezing to survive? Is it when we turn things from liquid to a gas? Or is it when we turn things from a liquid to a solid? Think about freezing ice or freezing meatballs or freezing bananas. Are we turning it into from a mushy substance to a solid? I would say yes. So you're just going to go through and click those. And I think it gives you a percentage at the end. I don't grade you on your percentage. I'm just seeing that you did it. But I would like for you to see what the best score, for you to do your very best is what I mean. And if you don't want to take this until you feel like you're totally ready, you are welcome to do the picture vocabulary, which I did assign to you guys. You don't have to turn anything in. It's just so you can see it easier. These are like flashcards and I love these. You can make it a slideshow. I think you can play with these and have it be like the word, the definition. So you can either choose for it to have the word there, what it is, or what the definition of it is. Or all 3 like that, which I like the one that has all 3. Next one, boiling point. What is boiling point? It's when something changes from a liquid into having that steamy, gassy vapor. That's the boiling point. Freezing point. You guys know that one. The temperature at which something changes. The material that something is going to affect its boiling and its freezing point. So if it's like plastic, that's going to be a different boiling point and freezing point than something like aluminum or glass or something else that would cause it to melt or freeze, any other material. So when we're talking about classifying matter, that goes into this unit too, because depending on what is inside, like for example, this plastic cup, this is Mila's cup. She's sleeping right now. this plastic cup, in order for me to melt this, it's going to have a different threshold than, for example, like something like this paper. In order for it to, well, these are both solid, so never mind. Forget what I'm saying. I'm going crazy. But from liquid to a gas, so like, I'm trying to give it, like water's boiling point is different than, say, lemonade or vinegar or soda or something like that. So that would make more sense. Sorry, I didn't mean to confuse you with that, talking about solids. Only liquids with that. Melting point, same thing, but it's how it melts. Evaporation, which we already talked about, when it evaporates into the air. Condensation, when it changes from a vapor or gas back into a liquid. So it's like a sauna. If you've ever been inside like of a sauna or like a heat bubble or something where you feel like after you take a shower, maybe if the door's closed, all of that steam from the shower goes on your mirror and you have like little droplets of water. It's turning from that gassy substance back into a liquid. It's cooling down. So it's not as hot. It's now becoming more room temperature. Celsius is how you pronounce this. It's a different scale than Fahrenheit, which I thought that would be the next one, but it's not. In the United States, we use Fahrenheit. Everybody else uses Celsius. You might think everybody else is backwards, but really, I think we're the ones that are backwards. So it's important to know both, though, and how it does change things. But Celsius, they usually use just a little bit easier because the freezing points and boiling points of water are exactly at 0 and 100, and it makes things a little bit easier to understand when you have such strong numbers like that instead of random numbers like 32, which is what it is for Fahrenheit. Very strange. Physical state, which is what we just talked about, it means like, is something a liquid? Is it a gas? So just go through these and kind of quiz yourself and see how well you know them before you go through our multiple choice assessment. So I'm going to go to the writing first, and then I'll walk you through the questions of the test. So this is the picture, and it looks like water that is boiling. You can see the little burner turned on, and I see bubbles rising, which means that a temperature change is going on here. Temperature measures the energy of the particles, so how fast they're moving. So the hotter something is, the more quickly the molecules inside are moving. That's why when you freeze something and all the molecules are frozen, nothing's happening. So the temperature is low. I looked so silly doing that on my camera here. Water is an interesting type of matter. It can change easily between all of the substances, liquid, solid, gas. Think about what must occur for water to change its state. What the answer is right there. Let me hide the answer. Sorry. What does water look like when it is a liquid? What about when it's a solid? Write about how water changes its state and how this can affect your life. So here's what I would say. When water is a liquid, it is wet and moist. It changes the physical property of whatever it touches, which is true, right? Because I wouldn't say physical property, but it changes the wetness, I guess you could say. So if it touches something else as a liquid, it's going to get that other thing wet. As opposed to if it's frozen, if it's an ice cube, it might make it cold. It won't necessarily make it wet. So I would say when water is a solid, the temperature is much higher or colder, much colder, and it lowers the temperature of whatever it touches. Think about it. When you get hurt, like ice, that's the reason why we put ice on things. It lowers the temperature, all of the blood rushing to that area. It lowers it and calms it down and stops the swelling. So it cools down. If you have ice on your face, it cools down that area. So it's lowering the temperature as well. And then how does it affect your life when it's a gas or when it's a liquid or whatever? That was just kind of what I did. I talked about how it affects things, like when I've spilled water all over my school papers. That's not fun. But yeah, just tell me like how it affects you. What's your favorite state of water if you have one? Do you prefer water when it's water or when it's ice or when it's gas, like steam? Do you like steam better? I know it's kind of a silly question, but I just want to see what you guys come up with, because I feel like it's something we use every day. And I think it's a pretty easy prompt. So I thought I would just go ahead and see what you guys came up with. Yeah. And then the last thing is our test, our multiple choice test. You'll have to excuse my brain. I'm not really thinking straight today. And it is late. And I'm sorry these videos are so late. I had the parade today and I did get to see some of you. All right. So I'm going to just go through the questions. I think there's 8. Oh, it looks like 10. Okay. So there's 10 questions. I'm going to walk you through them without giving you answers, just giving you hints. You're welcome. All right. So we'll go ahead and start. So question 1, it says, after a rainstorm, Naomi notices a puddle on the sidewalk. Later in the afternoon, she observed a change. So here's the before, after. What caused the puddle to disappear? Pretty simple. What makes water disappear? Where did it go? Did it just go down the sewer, the storm sewer? Probably not. If it's not raining anymore, we know precipitation. If we go back to this, if it was raining, what happens after the water collects on the floor? What happens after? Right there. So that's pretty easy. What happens when you leave ice cube on a table? There's water around the ice cube now. It looks like it's melting a little bit. So what would cause that ice to do that? Something is going to change that. If it's kept in a freezer, it's not going to do that. But if I take it out of the freezer and she leaves it out on the table, if you've ever left ice cream out, what causes it to melt like that? All right, number 3. Monique was reading a book on her windowsill. She noticed it started to rain and droplets started to stick to the window, kind of like your mirror after you shower or your water bottle sweat, as I call it. She went downstairs to eat, and then she noticed that once the rain had stopped, the drops that were on the window were no longer there. So what happened to the raindrops that were once on the window? So after condensation, whoops, not that one. After condensation, so this is the little droplets, what likely happened? So I'm going to say that they didn't freeze. They probably didn't melt. They didn't freeze or melt, but something happened. So it's one of these two. Did they go back up into the air? Or what happens during condensation anyway? The temperature is changing in some way. Doesn't freeze or melt, but the temperature is changing. That's all I'm going to say. Question 4, Steve scooped some ice cubes out of his drink and then he threw them on the concrete. Oh, I love doing that. What happened to the ice cubes what happened to them for them to begin to melt? So why did they start to melt? It's a warm day outside. So why would that happen? Was heat taken away? Was heat added? Was the ice placed somewhere cold? Or was the temperature of the ice decreased, meaning it got colder? Remember, hot goes up, cold goes down. So which one of these makes the most sense? Why something would melt? I'm melting. It's from Wizard of Oz, if you know that movie. I love that movie. It's my favorite movie ever. All right, question 5. What could happen to a liquid if a temperature of the liquid decreases? So remember, if the temperature is going down and it's getting very, 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 very cold, it's important that you remember that the temperature going down means that it's cold and temperature going up is hot. So like 100 degrees, super hot. It was probably like 80 degrees today. That's pretty hot. The lower it goes, 30, 20, 10, 0, you're getting super cold. So if the temperature is going down, what does that mean? Would it melt all over? Usually that happens when things go up, when it gets hot, right? Which one of these happens when it gets cold? Number 6, glass of ice water forms drops on the outside. Remember when I talked about your water bottle like sweating? That's kind of what this is. Which one of those did I say causes that? And evaporation is when it goes up to the air. Condensation is something else completely. And it's not melting or freezing. So you'll have to pick one of those two. Question 7, ice cube tray, puts it in a freezer. Takes the ice cube tray out and he's got ice. How does a freezer turn water into ice? You guys should know that one. I'm not even going to go through that one. That one's so easy. Popsicles. If you've ever made homemade popsicles, amazing. You can make anything into a popsicle, really. You can make a smoothie and make smoothie pops. It's great. All you need is popsicle sticks and an ice tray. He pours some juice into the molds. What must he do to finish making the popsicles? He put the liquid, so let's say he filled up the ice tray with juice, with apple juice. Does he need to put it in the oven to bake it? Does he need to put it in the freezer to make a popsicle? Does he need to put it in a dark closet, or does he need to leave it out on the kitchen counter? This one is very easy, guys, I would say. Number 9, Miss Shelley is making her spaghetti. She fills a pot with water, turns up the stove, waits for the water to heat up. You guys probably do this all the time. After a few minutes, the water is bubbling. What is that called? We do it every day. And the last question is, a container with ice was left in a warm room. So there's ice and it's warm in this room. After 3 hours, what's likely to happen? If you don't put it back in the freezer, what's going to happen? Is it going to grow bigger? Is it going to turn into a gas? Would it melt, or would it get colder? Again, I think this week's stuff is very, very easy. The hardest thing would probably be the writing, but I don't want you to get nervous about it. It's not really going to be a grade based on how smart your answer is. It's going to be, did you try and did you give me an answer that makes sense, really. That's it. That's all I'm looking for. So I believe in you guys. Rock on with science. Science is all around us every day. We see it everywhere we go. So I hope this video helped you and knock it out of the park. I will see you guys later. Goodbye.